So in our last mechanism, we learned how to take an alcohol, use MCPBA to form an epoxide, and then do an acid catalyzed ring opening to have our alcohols add anti to one another, right, plus the enantiomer. And we have anti-addition. And so naturally, you might be asking yourself is the question of, can we have some kind of syn addition? Right, and of course, our product here would be meso. So it's only one product, right? Do we have something that can do syn addition? Question mark, right? And the answer is to this is yes. So one option is to use OSO4, osmium tetroxide. And so let's go ahead and take a look at that. So we have our alkene, we have our osmium tetroxide. Our alkene attacks one of the oxygens over here. The double bond kicks onto the osmium, creating a lone pair. And then one of these double bonded oxygens attacks our carbon. And so we get this intermediate right here. Right, and you can see how now we've added these O's across this alkene in a syn format. And then the second step here varies. You can use a number of different reagents here. One of the common one is sodium bisulfite. So NaHSO3, that's sodium bisulfite in water. And what that's going to do is just basically cleave these osmium oxygen bonds and then reprotonate our alcohols or our oxygens to form our alcohols and get our final product. We won't take a look at the mechanism, but you can see what we've done here is syn dihydroxylation. Osmium is actually very toxic and expensive, so you can use other things to help along this reaction. So you can do this osmium and sodium bisulfite reaction. In that case, you're going to have to use a lot of osmium. Another option is to use a catalytic amount of osmium and then add some kind of oxidant to this. The most commonly used one is NMO. So if you see NMO, you can really just pay attention to osmium. We're not going to look at the mechanism of this at all. But here's NMO. If you're interested, it stands for N-methyl because there's a methyl on the nitrogen. Morpholine and oxide. Right, so N-methyl oxide essentially. And so this thing does the same exact reaction that we did before. So we'll get this syn addition. And of course, in this compound, it's meso as well, so we'll only get the one product. There are other ways to do this syn addition. Right, not use osmium tetroxide. So we can take our alkene here and we can add some potassium permanganate, CHEM112, along with some sodium hydroxide. But you have to do this under cold conditions, right? Low temperature conditions, and you'll get the syn addition. And the mechanism here is very similar to the osmium tetroxide. So we have our alkene, we have our permanganate, and we essentially follow the same mechanism here. To get our syn addition. And then we add some sodium hydroxide to cleave up these bonds. And eventually end up with our alcohol. So you might be asking, why use the osmium if it's toxic? Why not use the potassium permanganate? And the reason is that the potassium permanganate is a more powerful oxidant, and so often won't stop at the alcohol and may oxidize your alkene even further, which we'll learn about later.